We are going to continue on looking at the history of the discovery of the atom. And so we kind of left off with Dalton's atomic theory. But there were shortcomings of this theory. His theory said that atoms were indivisible, meaning they couldn't be broken down into anything smaller. And this was the smallest possible component of matter. And so this is not the case because we know about protons, neutrons, and electrons. And all three of these particles are smaller than the atom. So, an English physicist by the name of J.J. Thomson used a cathode ray tube and a cathode ray. And what he did was ended up discovering electrons. So a cathode ray tube is a device in which an electric current is passed through a gas at low pressure. The cathode ray is a beam that travels from the cathode end to the anode end. And so you can see here the cathode end, it's got this minus side because the cathode end is the negative side, and the anode end is positive. And so there's some electricity being passed through there. And then what happened was he used positively and negatively charged plates, or that's a fancy way of saying a magnet. And what he realized was when he pushed the negatively charged plate, the beam repelled or went away from the plate. Whereas when he used the positively charged plate, the positively charged plate attracted the beam to bend upwards. And so what this, you have to remember that like repels like, and positives, or let's say opposites, attract. And so we see that here where this negatively charged beam is being attracted to the positive plate, where then it's being repelled by this negative plate. And I strongly suggest you take a look at these links that describe these experiments in a little more detail. So he discovered that there had to be these negatively charged particles, and he originally called them corpuscles. And he determined that there was a charge to mass ratio of 1.8 times 10 to the 8th coulomb over grams. We will deal more with that probably this spring. So what he ended up discovering was that there are electrons, or negatively charged subatomic particles, present in atoms of all the elements. So then we bring into play Robert Millikan, and he determined the charge, or the strength of the charge of a single electron, and he used an oil drop experiment. What he found was that the charge of one electron was equal to 1 or negative 1.1 or 6.02 times 10 to the negative 19th coulomb. And so this C stands for coulomb, which is the unit of measure of a charge. He also determined that the mass of an electron was 9.11 times 10 to the negative 28th grams. So they're very, very small. So like I said, make sure you check out the links to these videos to get more details on these experiments. So scientists knew that atoms have no overall charge. And in Eugene Goldstein, he discovered evidence of a positively charged particle. He again used a cathode ray like J.J. Thomson. And he noticed that some rays traveled in the opposite direction from the cathode. This showed that those rays were composed of positively charged. And so this comes about the proton, the positively charged. Oh, let me spell it correctly for you guys. And then English physicist James Chadwick, he discovered the neutron, and this subatomic particle has no electrical charge. So now that all the subatomic particles had been discovered, what we were looking for, or what scientists maybe thought was there, was the nucleus. It was kind of difficult because it's very tiny in size. So scientists designed a model, or maybe almost a guess, of what they thought the atoms look like. So an atomic model was a goal to represent accurately the design of an atom based on the experiments scientists had already done. And so J.J. Thomson, when he found the electrons, he created what was called a plum pudding model. And us in the United States, we don't really know what plum pudding is, but the closest thing we can come to thinking about is more like a chocolate chip cookie. And Thomson said that the chocolate chips would be the negative charges randomly distributed throughout the cookie, and then the cookie dough would have an overall positive charge. And the opposites of the positives and the negatives would keep those negative chocolate chips with the rest of the cookie. Ernest Rutherford did a gold foil experiment, and what he's credited with is finding the nucleus. This is the tiny dense central core of the atom, and in it are protons and neutrons. And what he did was he shot alpha particles, and the thing about alpha particles is that they're positively charged, through a screen of gold foil. And I always think of this as like aluminum foil, but a piece of gold instead. And what he saw was that the majority of these positively charged particles went straight through and hit the back of the detecting screen. But every once in a while, one of these particles would deflect on that detecting screen, not off that straight path. It would be almost like they got deflected, and some even bounced straight back. And so what he thought was that instead of these positive particles just passing through, what they ended up doing was hitting another positively charged area, which we know as the nucleus, and that caused the deflection. So Rutherford's model became known as the nuclear model. And what this model stated was that the subatomic particles were in the middle, were the protons and the neutrons. And then he said then the electrons had to be distributed around the nucleus, and they occupy most of the mass of the atom. This model was good, except it did not completely address the way in which the electrons occupy the space around the nucleus, which is what we'll take a look at in our next video.